Right now, the Earth is moving through the galaxy at approximately 230 kilometers every second. You cannot feel it. Your room is completely quiet, the shadows are motionless, and your body rests heavily against the bed. In the time it took you to hear that first sentence, everything you have ever known moved roughly 1,000 kilometers through deep space. It is a violent, unimaginable velocity. Yet the glass of water on your bedside table sits perfectly still. The walls do not vibrate. The air in your room does not stir. This is the profound paradox of our existence. You are inside a silent, frictionless current being carried by an invisible force that acts on you without your knowledge or consent. This is not a metaphor, this is confirmed science. This is exactly what the data shows. We rarely think about motion on this scale. When we look up at the night sky, the stars appear fixed, pinned like pale lanterns to a dark dome. They look like a permanent background to human history. But that stillness is an illusion created by the limits of human perception. The reality is that absolutely nothing is still. The planet is spinning, the Earth is orbiting the Sun, and the Sun, carrying all its planets, moons, and drifting cometary dust, is hurtling through the Milky Way at over 828,000 kilometers per hour. Give that number a moment to settle in your mind. 828,000 kilometers per hour. Even at that staggering speed, the galaxy is so impossibly enormous that it takes the solar system about 225 million Earth years to complete just one single loop around the galactic center. Astronomers call this vast, sweeping cycle of motion a galactic year. It is the slow, unending heartbeat of cosmic time. When you measure history not in days or centuries, but in galactic years, the entire human story vanishes into a fraction of a second. In all of its 4.6 billion years of existence, our Sun has only circled the Milky Way about 20 times. It has only experienced 20 galactic years. The last time our solar system was in this exact part of its orbit, traversing this specific region of space, the supercontinent Pangaea had just begun to break apart, and the very first dinosaurs were only just beginning to emerge. The stars that shone in the night sky back then were entirely different from the ones you see today. The galaxy has turned, the neighborhood has changed, and the map has been completely redrawn. You are a passenger on a voyage that began long before consciousness existed, traveling through a structure that has been slowly assembling itself for over 13 billion years. We live inside a barred spiral galaxy, a massive, flattened disk of stars, gas, and dark matter. But because we are embedded deep inside that disk, we cannot look down on it from above. From our vantage point on Earth, the galaxy appears only as a hazy, luminous band stretching across the darkness of the night sky. It is like standing in the middle of a dense forest at midnight, looking along the line of the trees. You cannot see the shape of the entire forest, you only see the thick depth of the timber surrounding you. For a long time, this limited perspective hid the true nature of our surroundings. But through careful measurement, through tracking the faint radio whispers of cold hydrogen and mapping the exact velocities of billions of stars, the true architecture of our home has been revealed. We now know that our solar system resides in a relatively quiet, calm region of the galaxy. We are nestled within the Orion Spur, a minor, unassuming branch of stars located between two much larger, busier spiral arms. It is a gentle, cosmic suburb. Here, the space between stars is generous. Massive, catastrophic supernovae are rarer here. Destructive pulses of radiation are less frequent. It is precisely this quietness, this lack of dramatic cosmic weather, that likely gave life on Earth the long, uninterrupted stretches of time it needed to slowly evolve and take root. We exist because we are in a calm pocket of a spinning sea. But that sea is not empty. Even as you lie there, the space around you is active. Trillions of ghostly neutrinos, forged in the nuclear fires of distant stars, are passing through your body every second. High-energy cosmic rays, launched by ancient supernovas, are slipping through the roof of your home, traveling at nearly the speed of light, leaving absolutely no trace. Between the stars lies the interstellar medium, a sprawling, delicate mixture of diffuse gas and tiny, microscopic grains of dust. It is far thinner than the air you are breathing right now, but it weaves through the galaxy like a thin fog. Our sun is currently drifting through these faint clouds, guided by the collective gravitational pull of hundreds of billions of other stars. Everything is moving together in a highly synchronized, staggering choreography. The Earth, the Sun, the local dust clouds, and the neighboring stars are all participating in the same grand rotation. But as our measurements have grown more precise, a deeper, more unsettling reality has emerged. When physicists calculate the mass of all the glowing stars, all the swirling gas, and all the dense dust within the Milky Way, the math completely fails. Based entirely on the visible matter we can detect, the galaxy should not be able to hold itself together. The outer edges of the galaxy are spinning far too fast. By all the established laws of Newtonian physics, the Milky Way should have ripped itself apart eons ago, scattering its stars into the cold intergalactic void like leaves blown away in a sudden storm. And yet, they remain. The galaxy turns like a solid wheel. Something unseen is gripping the Milky Way. Something completely invisible is pressing down on the spinning disk, holding the stars in their lanes, providing an underlying framework of gravity that outweighs all the visible matter in the galaxy many times over. We do not know exactly what it is, but we know it is there. The visible stars are merely the decorative lights hung upon an immense, dark scaffolding. We are being carried by a current we cannot feel, through a structure we cannot fully see, held together by a ghost. The Earth orbits the Sun orbits the core, and the entire galaxy is rushing towards something unseen. The investigation is ongoing, and we are inside this problem right now. If you enjoy deep, measured investigations like this, subscribe now. The investigation begins here. For a very long time, we thought we knew exactly what our local cosmic neighborhood looked like. If you were to look at a traditional map of the Milky Way drawn just a decade ago, you would see a very specific, orderly image. You would see a magnificent, flattened disk of stars, a perfect, symmetrical pinwheel turning quietly in the dark. In this classical view, the spiral arms were imagined as neat, flat, concentric circles wrapped tightly around the galaxy's glowing core. Astronomers understood these sweeping structures not as permanent groups of the exact same stars, but as continuous density waves. They were thought to be flat, two-dimensional ribbons of interstellar traffic. The theory was simple and elegant. As clouds of gas and dust drifted through the cosmic plane, they would encounter these invisible waves of higher density. The gas would naturally slow down, become compressed, and eventually collapse under its own gravity, triggering the birth of bright new stars. Those newborn stars would then light up the spiral arm in brilliant curls of blue and white, before eventually drifting out of the wave and continuing their calm journey through the flat disk. It is an incredibly comforting picture. It makes the galaxy feel like a calm, predictable clockwork mechanism, a vast spinning record playing a silent, repeating tune in the dark. We liked this map because it made logical sense. We understand flat surfaces. When we look at diagrams of our own solar system, we see the planets orbiting the Sun in a relatively flat plane, like marbles rolling on a smooth, dark tabletop. It was completely natural to assume the galaxy behaved the exact same way on a much grander scale. We naturally imagined that the billions of stars, the sprawling clouds of cold molecular hydrogen, and the radiant stellar nurseries all rested evenly upon this singular, flat surface, like dust settled completely flat on a spinning wheel. But the map was wrong. The complication lies in the fact that mapping a galaxy from the inside is a profoundly difficult and frustrating task. We are deeply embedded within the galactic disk. Attempting to chart the true three-dimensional shape of the Milky Way from Earth is exactly like standing in the middle of a dense, overgrown forest at midnight, looking along the line of the trees and trying to draw an accurate map of the entire woods. You cannot see the overall shape of the forest from that vantage point. You only see the thick depth of the timber immediately surrounding you. Furthermore, the space between the stars is not empty. Thick curtains of interstellar dust, made of microscopic grains of carbon and silicates, weave heavily through the spiral arms. These dense dust lanes absorb visible light, throwing massive, impenetrable shadows across our line of sight. For centuries, we could only guess at the true three-dimensional structure of the local spiral arms because the dust blocked the view. We could measure the faint radio whispers of hydrogen gas passing through the dark, but depth perception in deep space is notoriously deceptive. We were looking at a flattened, compressed picture, completely unaware of the immense topography hidden within it. As our instruments improved and as observations became astonishingly precise, that simple, orderly picture began to unravel. With the launch of incredibly sensitive observatories like the Gaia spacecraft, astronomers began to map the exact positions and motions of over 1 billion stars in true three-dimensional space. We learned that the galaxy is far more complex, layered, and strange than a simple flat pinwheel. Through this patient, meticulous measurement, a completely new structure emerged from the darkness, a discovery that fundamentally alters the shape of our local cosmic neighborhood. Astronomers found an unbroken, continuous spine of star-forming gas. It is an unimaginably massive structure, stretching for a staggering 9,000 light-years through our local region of the Milky Way. Let that measurement linger in your mind for a moment. 9,000 light-years. Even light, the absolute fastest thing in the universe, takes 90 centuries just to travel from one end of this structure to the other. This colossal formation contains millions of young stars, vast stellar nurseries, and deep, dark clouds of raw, unlit molecular hydrogen. It is a continuous, interconnected river of cosmic creation. But the most startling and important thing about this massive structure is not its scale, it is its shape. It is not flat, it does not rest evenly upon the galactic plane. This is confirmed science. This is what the data says. Instead of a flat, predictable ribbon, this colossal line of stars and gas snakes violently up and down. It rises high above the galactic disk, crosses the midplane, and then plunges deep below it, before rising again. It is a massive, undulating, three-dimensional ripple cutting straight through our neighborhood. Scientists have named it the Radcliffe Wave. To truly understand its physical presence, do not picture a clean, mathematical wave drawn on a chalkboard. Do not think of a rigid, geometric line that is far too abstract for something this real. Instead, picture the undulating ridges of a corrugated metal roof. Imagine running your hand slowly over those rising and falling metal grooves, feeling the solid, repeating peaks and the deep, plunging valleys. That is the exact physical shape of the star-forming gas in our local spiral arm. It is heavily textured, it has dramatic height and depth. Or imagine a heavy, thick rope laid out straight on the ground. If you step forward, pick up one end of that heavy rope and flick it hard with your wrist, a massive, rolling ripple travels down its entire length. The wave lifts the heavy woven fibers up into the air, suspends them for a fraction of a second, and then pulls them heavily back down to the ground, only to rise again. The Radcliffe wave is exactly like that moving, rolling ripple, but instead of woven hemp, it is made of glowing, star-forming gas, cold, dark dust, and millions of brilliantly burning suns stretching across 9,000 light-years of deep, silent space. The galaxy is not a smooth, flat record. The map you were taught is incomplete. The reality is buckled, warped, and rippling with immense, slow-moving architecture. The structure of our home is heavily corrugated, and we are moving through it. And here is the most profound part of this discovery. You are not just a spectator looking at this wave from afar. Our solar system is actively passing through this massive ripple right now. Our sun is actively surfing this exact wave at this very second. As you lie in the quiet of your room, feeling the heavy, comforting stillness of your mattress and the slow, steady rhythm of your breathing, you are physically participating in a massive, three-dimensional undulation. We are fully embedded inside the wave. The Earth is not just orbiting the Sun in a flat, even circle. The Sun is not just orbiting the galactic center on a flat, unbroken track. We are swaying, rising, and diving through a colossal crest of ancient gas and starlight. Like a cork bobbing gently in slow motion on a vast, dark ocean swell, the Sun drifts above and below the galactic plane over tens of millions of years. Right now, the solar system is climbing the slope of the Radcliffe wave. We are traveling through the undulating ridges of that cosmic roof, surrounded by the towering, invisible architecture of our home galaxy. The silent velocity that carries us forward is not just pushing us through empty, level space. It is lifting us up the face of an unimaginably vast wave of creation. You cannot feel the rise and fall. The air in your dark room remains perfectly still. But the upward motion is real. The wave is real. This is the reality of your address in the cosmos. You are inside a structure so large that it takes light 90 centuries to cross it, and it is carrying you on a slow, sweeping ride through the dark. You are safe. You are secure, but you are never, ever completely still. As the sun continues its slow climb up the face of this invisible wave, it brings you with it, gliding silently through the night. The motion is impossibly vast, but profoundly gentle. It asks nothing of you but to close your eyes, let go of the day, and allow the wave to carry you softly forward into the dark. As we ride the undulating ridges of the Radcliffe wave, moving gently up and down through the galactic plane, we are simultaneously participating in a much grander, far more violent motion. The entire Milky Way is spinning. It is a vast, rotating carousel of hundreds of billions of stars, sweeping clouds of gas and sprawling dust lanes, all turning together in the dark. For centuries, this rotation seemed perfectly logical. It made sense because we assumed the galaxy operated by the same reliable, comforting rules that govern our own solar system. The classical laws of Newtonian physics offer a deep sense of order. They tell us that gravity acts like an invisible tether, and its strength fades predictably as distance increases. If you look at the planets orbiting our sun, this rule is displayed in perfect, elegant motion. Mercury, nestled tight against the sun's immense gravitational pull, whips around its orbit in a frantic 88 days. But far out in the frozen, dark suburbs of the solar system, Neptune drifts along at a much slower, leisurely pace, taking 165 Earth years to complete a single, sweeping orbit. The rule is simple and unbending. The farther away an object is from the central mass that holds it, the slower it must travel. Astronomers naturally expected the Milky Way to follow this exact same law. They assumed that the stars packed tightly near the galactic core would race through their tight orbits, while the stars residing at the far, desolate outer edges of the disk would glide along at a much slower, calmer pace. The galaxy, they believed, was just a solar system written on a larger canvas. But when instruments finally grew sensitive enough to measure the exact velocities of those distant outer stars, the math completely collapsed. The classical rules of physics broke down. The outer edges of the Milky Way are not moving slowly. The stars in the galaxy's remote outskirts are racing through the dark, orbiting the center almost as quickly as the stars located deep within the crowded core. This is not a minor discrepancy. It is a profound anomaly that fundamentally shatters our understanding of gravity. Based entirely on the visible matter we can detect, every burning star, every thick lane of dust, and every sweeping cloud of molecular hydrogen, the outer regions of the galaxy are spinning far too fast. If you spin a merry-go-round at a violent speed, the riders are thrown outward, unable to hold on. The same principle applies to a rotating galaxy. At the staggering velocities we have measured, the gravity generated by all the visible matter in the Milky Way is simply not strong enough to keep a grip on its outermost stars. By all established logic, the Milky Way should not exist in its present form. The entire structure should have ripped itself apart eons ago. The outer stars should have been flung completely out of their orbits, scattered into the cold, intergalactic void like leaves, blown away in a sudden, violent storm, and yet they remain. The galaxy turns like a solid, unbroken wheel. It holds its shape perfectly, defying the very physics that should have dismantled it. The only possible explanation is that our inventory of the universe is fundamentally incomplete. There must be something else providing the massive gravitational grip needed to keep the stars anchored in their lanes. The visible light of the galaxy is lying to us about its true mass. We call this hidden presence dark matter. But to call it missing mass is to do it a disservice. It reduces something terrifyingly immense into a simple accounting error. Do not think of dark matter as just a mathematical placeholder or a distant cloud of black dust. It is a profound physical reality. It is the invisible scaffolding that gives the galaxy its structure, weaving through the spiral arms and extending far beyond the outermost stars. Dark matter outweighs all the visible matter in the galaxy many times over. A full beat of silence. Consider what that means. Every brilliant blue giant, every sprawling stellar nursery, every ancient red dwarf, every planet, moon, and drifting grain of cosmic sand combined makes up only a tiny fraction of what the Milky Way actually is. We live in a galaxy made almost entirely of something we cannot see, cannot touch, and do not understand. This unfeeling substance does not emit light. It does not reflect light. It does not block light. It passes through ordinary matter as if it were not even there, but its gravitational influence is absolute. Without it, the Milky Way would fly apart into chaos. Because it is completely invisible and interacts only through gravity, it is easy to imagine dark matter as something distant, a mysterious framework existing only in the deep void between distant suns. But that is the ultimate illusion. This unseen framework is not just out there, it is here. It occupies the very room you are sleeping in right now. As you lie in your bed, breathing slowly in the dark, the space around you feels empty. The air is still. The walls of your home are solid and protective. You feel entirely secure in your isolated environment. But that emptiness is an illusion. You are submerged in an ocean of invisible mass. At this exact second, strands of dark matter are passing silently through the roof of your house. It is drifting through the walls. It is slipping effortlessly through the blankets on your bed and passing directly through your own body. You cannot feel it. It does not brush against your skin or stir the air in your room. It is entirely indifferent to your presence because it does not interact with the electromagnetic force. Your hands cannot touch it, and your eyes cannot register its shadow. You are sharing your most intimate, quiet space with an immense, silent presence that acts upon you without your knowledge or consent. The unease you might feel at this thought is entirely natural. We are biologically wired to trust what we can see and touch. We rely on the physical world to feel grounded, to realize that the vast majority of the universe's substance is utterly undetectable and that it is flowing through your living space at this very moment brings a sudden, heavy awareness of our own limited perception. We are blind to the true architecture of our home. The luminous spiral arms we so carefully map, the glowing nebulae we admire in telescope images, the stars we wish upon, they are not the galaxy itself. They are merely the decorative lights hung upon an immense, unseen framework. The true Milky Way is a massive, invisible structure, and the glowing stars are simply the dust caught in its gravitational web. We are held together by a ghost. Without this unfeeling, unseen framework, the galaxy would rip itself apart, and our solar system would be cast adrift into the freezing blackness of intergalactic space. We exist because this ghost holds us in place. We orbit the sun, and the sun orbits the core, held secure by a scaffolding that we can never touch, moving silently through a current we cannot feel. Far beyond the unseen scaffolding of dark matter that slips silently through your room, a different kind of presence anchors our galaxy. To find it, you must cast your mind roughly 25,000 light-years inward, past the Orion Spur, past the sweeping rivers of cold molecular hydrogen, and look directly toward the constellation Sagittarius. If you were to look in that direction on a clear, dark night, you would not see the true center of the Milky Way. Your view is blocked. Thick, heavy curtains of interstellar dust made of microscopic grains of carbon and silicates hang in the space between our solar system and the galactic core. These sprawling dust lanes absorb visible light, throwing massive shadows across our line of sight and hiding the bustling heart of the galaxy. But when astronomers look through these veils using infrared and radio telescopes, the darkness dissolves into an overwhelming, concentrated brilliance. The core of the Milky Way is a crowded, luminous metropolis. Here, millions of ancient stars are packed together in a space so tight that the region glows with an intense, overlapping radiance, and the night sky on a planet in this region would never truly grow dark. It is a chaotic, radiant environment, but at the very heart of this brilliant storm, there is a point of absolute, invisible stillness. Deep inside the glowing bulge of our galaxy lies a supermassive black hole. Astronomers call it Sagittarius A star. It contains roughly 4 million times the mass of our Sun. Give that measurement a full moment of silence. 4 million entire suns crushed together into a single, invisible point. Despite containing this staggering amount of mass, the physical space this black hole occupies is almost unbelievably small. The entire event horizon of Sagittarius A star could fit comfortably within the orbit of Mercury in our own solar system. It is a point of gravity so dense and so absolute that it bends the very fabric of space-time around it, forcing nearby stars to whip through tight, invisible loops at thousands of kilometers every second. But here is the most important thing about the center of our galaxy right now. It is quiet. Sagittarius. A star is currently resting. It is barely feeding. Occasionally, a drifting cloud of gas or a stray asteroid falls inward, producing a brief, sudden flare of X-rays as the material heats up and slips beyond the event horizon. But for the most part, the supermassive black hole at the center of the Milky Way sleeps in the dark. It emits very little radiation, It simply sits in the dark, acting as the silent, unyielding gravitational anchor for the stars swirling tightly around it. Because it is so quiet today, it is easy to assume it has always been this way. We are naturally inclined to look at the calm, slow-turning spiral of the Milky Way and believe that it is a peaceful structure. But the galaxy carries the memory of its violence. When astronomers look far above and far below the flat plane of the galactic disk, they see something that shatters the illusion of perpetual calm. Towering over the center of the Milky Way are two colossal, ghostly lobes of high-energy light. They rise directly upward from the galactic core and plunge directly downward beneath it, shaped like two halves of an immense, twisting hourglass. These are the Fermi bubbles. They are utterly invisible to the human eye. You cannot see them when you look up at the night sky because they do not emit visible starlight. They glow entirely in gamma rays and X-rays, the most energetic and extreme wavelengths of light in the universe. They are impossibly huge. Each bubble stretches for tens of thousands of light years into the empty space of the galactic halo. For years after their discovery, these towering structures were a profound mystery. They are clearly the remnants of an unimaginably powerful explosion, a cataclysmic eruption of energy that blasted outward from the very center of the galaxy, carving vast cavities into the halo and leaving behind a glowing residue of radiation. But for a long time, astronomers treated this as an abstract ancient event. They assumed that whatever carved these massive bubbles must have happened in the deep, unknowable past, billions of years before the Earth was fully formed. But the map was wrong. The complication is that the universe is far more dynamic than we thought. This is confirmed science. This is what the data says. The explosion that created the Fermi bubbles was not a relic from the dawn of time. It was a highly specific, cataclysmic event known as a Seyfert flare. The sleeping giant at the center of our galaxy woke up, consumed an enormous amount of matter, and blasted twin jets of radiation outward with enough force to pierce the galactic disk. And we now know the exact timeline. This cataclysmic eruption from the core happened a mere 3.5 million years ago, in the slow, sweeping scale of cosmic time. Where a single orbit of our Sun takes 225 million years, 3.5 million years is not ancient history. It is barely a fraction of a second ago. It happened yesterday. To truly understand the existential weight of this timeline, we must anchor it to the ground. We must connect the towering, invisible gamma-ray bubbles in space directly to the dirt beneath our feet. 3.5 million years ago, the Earth looked remarkably familiar. The continents were roughly in their present positions. The oceans were vast and blue, and on the warm, sweeping plains of the African savanna, early hominids were already walking upright. Australopithecus was living, breathing, and foraging beneath the open sky. They were our ancient ancestors, possessing a quiet, emerging awareness of the world around them. When the sun dipped below the horizon, they sought shelter and looked up at the very same stars we see, scattered across the dark canopy of the Earth. But one night, the sky changed. When the Seyfert flare erupted from Sagittarius A, the center of the Milky Way ignited. The radiation from the supermassive black hole blasted outward, slamming into the gas and dust surrounding the core. This collision created a brilliant, blinding flash of light that traveled 25,000 light-years across the silent vacuum of space until it finally washed over the Earth. As early hominids walked across the African savanna, the center of our galaxy flared with a blinding light in the night sky. For a brief, terrifying, and magnificent period, a second moon appeared in the dark. The galactic core, normally hidden behind thick curtains of black dust, burned so intensely that its light pierced the veil. It would have cast long, strange shadows across the tall grass of the savannah. It would have reflected in the quiet, dark waters of ancient lakes. The hominids looking up would have had no words for what they were seeing, no context for the scale of the event. They only knew that the night was no longer dark, and the sky had caught fire. The light eventually faded. The supermassive black hole exhausted its fuel, quieted down, and returned to its deep sleep. The sky returned to its familiar, gentle patterns. The hominids continued their long, slow evolutionary march forward. But the energy from that explosion never stopped moving. The Fermi bubbles we observe today are the expanding shockwaves of that exact event. The echo of that light is still expanding into the cold, intergalactic void right now. As you lie in your bed, breathing slowly in the quiet of your room, you are resting inside a galaxy that is still ringing like a struck bell. This is the reality of our place in the universe. We are not separated from the violent, magnificent machinery of the cosmos. We are deeply embedded inside it. The light that illuminated the faces of our ancient ancestors is an ancient memory we can measure today. Astronomers do not just point their telescopes at the Fermi bubbles to look at interesting shapes in the dark. They are looking at the direct physical residue of a light that washed over the Earth while humanity was just beginning to take its first steps. It is easy to look at the immense scale of the Milky Way and feel insignificant. It is easy to feel small when confronted with a 4 million solar mass black hole or structures of radiation that stretch for tens of thousands of light years. But there is a profound grounding comfort in knowing that we are directly connected to these events. The history of the galaxy and the history of life on Earth are not parallel tracks, they are the exact same timeline. The sleeping giant in the center of our home may wake again in the distant future. It may remain quiet for millions of years more, but the echo of its last waking breath is still expanding through the dark, a gentle reminder that the universe is alive, it is moving, and we are an active, enduring part of its story. When we look out into the night sky, it is incredibly easy to be deceived by the simple, beautiful shape of the Milky Way. We are naturally drawn to the glowing, flat plane of the galactic disk and the brilliant, curving spiral arms. Because this is where the brightest stars live, and because this is the shape we are most familiar with, we naturally assume that this sweeping pinwheel is the entire galaxy. We imagine it as a pristine, singular creation, a beautifully organized structure that spun itself out of the dark billions of years ago and has remained perfectly intact ever since. But this is an illusion. The Milky Way is not a pristine galaxy. To find the true history of our cosmic home, you must look away from the bright, crowded spiral arms. You must cast your mind far above and far below that flat, glowing disk, out into the vast, nearly invisible sphere of space that envelops the entire structure. This immense, shadowy region is called the galactic halo. It stretches for hundreds of thousands of light years into the freezing intergalactic void. It is sparse, it is quiet, and it is overwhelmingly dark. But the halo is not empty. It is a graveyard, and it contains the quiet, enduring evidence of our galaxy's violent, cannibalistic past. The Milky Way did not grow in isolation. It did not peacefully assemble itself out of a single cloud of primordial gas. Our galaxy is a composite, a massive patchwork structure built from the shattered wreckage of consumed dwarf galaxies. Over billions of years, as smaller, faint galaxies drifted too close to the Milky Way, they were caught in our galaxy's immense, inescapable gravitational pull. When a dwarf galaxy falls into the Milky Way, It is not destroyed in a sudden, dramatic explosion. The universe operates on a much slower, much more patient scale. Instead, the smaller galaxy is subjected to massive tidal forces. It is slowly, meticulously dismantled. Over millions of years, the immense gravity of the Milky Way pulls the smaller galaxy apart, peeling its stars away layer by layer. The dwarf galaxy's structure dissolves, but its stars are not extinguished. Instead, they are stretched out into long, delicate, glowing ribbons that wrap around the Milky Way in sweeping arcs. Astronomers call these ribbons stellar streams. They are the ghostly, lingering trails of dead galaxies, forever trapped in the halo of the giant that consumed them. To understand how astronomers can possibly map these ancient, silent acts of consumption, you do not need to understand complex astrophysics. You only need to think of a piece of wood. Imagine running your hand over a smooth, polished wooden table in your home. If you look closely at the surface, you do not just see a uniform color. You see the grain. You see the sweeping, parallel lines of the wood, representing the slow, steady growth of the tree over many years. But occasionally, that smooth, orderly pattern is interrupted. You will see a dark, dense knot. You will see the grain swirl and buckle around that knot in tight, complex curves. When you look at that knot, you are looking at a preserved memory. The swirls and knots in a piece of wood show you exactly where a branch used to be, long after the branch itself has been cut away. The tree carries the structural memory of its own growth. The Milky Way behaves in the exact same way. When astronomers use incredibly precise instruments, like the Gaia spacecraft, to map the exact positions and motions of billions of stars, they are looking at the cosmic grain of our galaxy. Most stars flow in smooth, predictable, parallel lanes around the galactic center. But occasionally, astronomers find massive, twisting knots in the data. They find massive streams of stars that do not match the surrounding flow. These stars move at strange, tilted angles. They carry entirely different chemical fingerprints, proving they were not born in the same environment as their neighbors. These stellar streams are the knots in the cosmic wood. They show us exactly where a separate, alien branch used to exist, long after the dwarf galaxy itself has been shredded and consumed. Through this patient mapping, a deeply complex and slightly unsettling picture has emerged. We are living inside a cannibal. And one specific knot in the grain of our galaxy is so massive, so profound, that it fundamentally altered the course of the Milky Way's history. This is confirmed science. This is exactly what the data shows. Roughly 10 billion years ago, when the Milky Way was still young and its structure was still settling into place, an enormous dwarf galaxy drifted directly into our path. Astronomers have named this doomed galaxy Gaia Enceladus. It was massive, filled with millions of stars, sprawling clouds of gas, and its own heavy envelope of dark matter. When Gaia Enceladus collided with the young Milky Way, it did not just add a few wandering stars to our halo. It was a catastrophic, foundational merger. The impact violently stirred the Milky Way's original stars, throwing them into higher, chaotic orbits and swelling the galaxy's thick disk. The dwarf galaxy was completely ripped apart, its structural integrity shattered. But its stars survived. They were absorbed into our home, scattering across the sky, forever woven into the tapestry of the Milky Way. When we look up at the night sky today, we cannot tell the difference with our naked eyes. The stars of Gaia Enceladus look exactly like our own stars. They shine with the same calm, steady light, but their chemistry and their motion betray their alien origin. They are the immigrants of the night sky, the surviving remnants of a completely different world. And this is where the story of the cannibal galaxy reaches out from the freezing dark of the galactic halo, slips through the roof of your home, and rests directly inside the room with you. We are deeply accustomed to thinking of the universe as something out there. something separate from the quiet, domestic safety of our beds. But the universe does not recognize that boundary. Every single atom in your body that is heavier than helium was forged in the blinding nuclear furnace of a star. The iron pumping through your blood, carrying oxygen to your brain as you rest, the calcium fortifying your bones, holding your skeleton together in the dark, the carbon that forms the foundational architecture of your very DNA. None of it was created on Earth. It was all manufactured in the core of a star and then violently blasted into space when that star died in a supernova, drifting for eons before eventually coalescing into our solar system. We have always found a gentle, poetic comfort in this fact. We are made of stardust. It connects us to the glowing spiral arms of our home galaxy. But understanding the cannibalistic history of the Milky Way introduces a profound, unsettling complication to your own existence, because the Milky Way has spent billions of years shredding and consuming other galaxies, pulling their stars and their gas into our own spinning disk. The raw materials of our cosmic neighborhood are thoroughly mixed. The solar nebula that eventually formed our sun, our planet, and your body was not just made of native Milky Way material, it was a blend of everything the galaxy had ever eaten. As you lie there right now, breathing slowly, feeling the weight of your own physical form, consider the true origin of the elements inside you. It is a statistical certainty that some of the atoms inside your body right now did not originate in the Milky Way. The iron in your blood might have been forged in the heart of a star that was born inside Gaia Enceladus. That star lived its entire life and exploded in a completely alien galaxy. Its remnants were violently dragged into the Milky Way during a cosmic collision 10 billion years ago, drifting across intergalactic space, mixing with native gas, before eventually finding their way to a small blue planet, and finally, into you. You are not just made of the Milky Way. You are a biological mosaic constructed from the shredded wreckage of consumed worlds. You are carrying the physical remnants of alien galaxies inside your own body right now. As you rest in the quiet of your room, perfectly still, you are an active, breathing repository of intergalactic history. The cosmos is not just an environment that surrounds you, it is the very material you are using to perceive it. You belong to this galaxy, but parts of you remember a completely different sky. You are the cannibal's tapestry woven into human form, resting quietly in the dark. To truly understand the scale of the motion carrying you tonight, we must pull our perspective back, far beyond the glowing tapestry of the spiral arms, and step out into the freezing, breathless expanse of intergalactic space. We have spent our time mapping the internal machinery of our home, tracing the slow orbits of ancient suns and the gentle undulations of star-forming gas. But the Milky Way does not exist in isolation. Our galaxy is not a static object pinned to the dark fabric of the universe. It is a physical structure, and like all physical structures, it is subject to the immense, unyielding laws of gravity. Together with the Andromeda Galaxy, the Magellanic Clouds, and dozens of smaller, fainter companions, the Milky Way forms a collection known as the Local Group. Bound together by invisible threads of mutual gravitational pull, this entire neighborhood of galaxies is drifting through the wider cosmic ocean as a single, massive family. But this drift is not a slow, aimless wandering. At this exact moment, the Milky Way and our entire local group are racing across the universe at a staggering, almost incomprehensible speed. We are hurtling through the ancient, lingering radiation of the cosmos at over 2 million kilometers per hour. Give that number a moment to settle in your mind. 2 million kilometers per hour. In the brief pause between your breaths, our entire galaxy, every star, every nebula, every planet, and the quiet room you are resting in right now has been carried roughly 1,700 kilometers through deep space. For decades, astronomers mapped this violent velocity and asked the natural question, toward what? If we are falling through space at millions of kilometers per hour, what is pulling us? The answer was found in a massive, hidden region of space that astronomers named the Great Attractor. It is an unimaginably colossal basin of gravity, a convergence point pulling thousands of galaxies, including our own, toward its center. But finding it was one of the most frustrating challenges in the history of astronomy. We cannot see the Great Attractor directly. It lies perfectly concealed behind the dense, dusty plain of our own Milky Way. It is exactly like trying to look out a window to see a massive approaching storm, only to find that a thick, impenetrable layer of grime on the glass completely blocks your view. Astronomers call this obscured region the zone of avoidance. We cannot see the monumental mass that is pulling us. We can only feel its influence on the motion of our galaxy. For a long time, the Great Attractor seemed to be the final answer. We are falling toward a massive concentration of distant galaxies. It was a neat, satisfying explanation for the silent velocity of our home. But the map was wrong, or rather, the map was incomplete. When instruments grew sensitive enough to map the exact flow of thousands of surrounding galaxies, a profound complication emerged. The mass of the Great Attractor, even combined with larger superclusters lying far beyond it, is simply not strong enough to account for the staggering speed at which the Milky Way is moving. The gravitational pull coming from the front is not sufficient to drag us this fast. There is another half to the equation, a deeply unsettling but fascinating reality that changes the entire nature of our journey. To understand it, you must look in the exact opposite direction. You must look directly behind the Milky Way. Far behind our galaxy, in the opposite direction of our travel, there are no massive superclusters of glowing stars. There are no bustling cosmic metropolises or heavy concentrations of dark matter. Instead, there is a sprawling, desolate region of absolute nothingness. It is an immense, empty bubble in the structure of the universe, hundreds of millions of light-years across, where practically no galaxies exist at all. Astronomers call this dead void the dipole repeller. In the pure physics of the cosmos, a void does not just sit empty. Because it completely lacks mass, it acts as a powerful opposing force. While the heavy superclusters ahead of us are pulling the Milky Way forward, this colossal empty void behind us lacks any gravity to hold us back. The result is a profound physical repelling action. We are not just falling, we are actively being pushed away from an immense dead void of nothingness directly behind our galaxy. This is confirmed science. Multiple independent teams confirmed this mapping of local space. Our galaxy is suspended between two monumental extremes. We are caught in a cosmic tug-of-war, trapped between the dense, heavy gravity of the Great Attractor pulling us forward and the desolate, unyielding emptiness of the dipole repeller pushing us from behind. The combination of these two forces creates the violent 2 million kilometer per hour current that is carrying our home through the dark. And you must understand, this is not an abstract piece of trivia about distant space. We are inside this problem right now. The realization that our entire galaxy is caught in a cosmic wind at this exact moment shifts the very foundation of how you experience the space around you. As you lie in your bed, your body feels heavy against the mattress. The air in your room is quiet and completely undisturbed. The walls of your home offer an illusion of perfect, anchored stillness. But that stillness is only a trick of human scale. You are physically participating in this intergalactic motion. At this very second, the immense, dead void lying millions of light years behind our galaxy is actively pushing against the cosmic region that contains the Milky Way. It is pushing against the Orion Spur. It is pushing against our solar system. It is pushing against the Earth, and it is pushing against the exact room you are resting in. You are caught in a cosmic wind. You are a traveler riding a wave generated by the largest structures in the known universe. It is entirely natural to feel a brief sense of unease when confronted with the invisible nature of this reality. We want to believe that the ground beneath us is stationary. To know that you are being hurled through intergalactic space by the repelling force of a massive dead void without your knowledge or consent is a staggering realization. It strips away the illusion of our domestic isolation. But there is no danger here. There is only awe. Because the scale of this motion is so unfathomably vast, the violence of our speed translates into perfect, silent peace. The push from the void and the pull from the attractor operate on timelines that dwarf the entire existence of the Earth. This journey unfolds over billions of years, too slow for any single generation or even any single species to notice the change. We will never arrive at the great attractor. In the deep future, the expansion of the universe itself will stretch the fabric of space, pushing the attractor away from us faster than we can ever fall toward it. We are participating in a journey that has no destination. We are simply moving, drifting in the balance between presence and absence, between heavy mass and silent void. As you breathe slowly in the dark, let the weight of this cosmic wind settle around you. You do not need to fight the motion because you cannot. You do not need to brace yourself against the speed because the galaxy carries you with infinite, frictionless care. You are resting safely inside a vessel of hundreds of billions of stars suspended between a great light and a great emptiness, gliding smoothly and silently through the dark. We have moved through the crowded, glowing center of our home. We have stood in the bright, busy lanes of the spiral arms. We have felt the violent push of the intergalactic wind. Now we must leave the noise behind. We must slow the pacing down. It is time to prepare for deep sleep. To do this, we must travel outward. We must leave the flat, spinning disk of the Milky Way. We must move to the very outermost edges of our cosmic neighborhood. As we travel upward, the bright band of the Milky Way falls away beneath us. The brilliant blue stars fade. The dense, sprawling clouds of illuminated dust disappear. The space around us opens up. It becomes overwhelmingly dark. The light thins out into a pale, quiet whisper. You have entered the galactic halo. The halo is a vast, nearly invisible sphere. It completely surrounds the flat disk of the galaxy. It is unimaginably large. It stretches for hundreds of thousands of light years into the freezing intergalactic void. If the flat disk of the Milky Way is like a brightly lit plate, the halo is an immense, dark room that the plate sits inside. Out here, the space is sparse. It is uncrowded. It is deeply, profoundly quiet. The frenzy of star formation does not happen here. The dramatic explosions of massive suns are absent. The environment is settled. It is wrapped in a permanent, undisturbed calm. But the halo is not empty. Even in this deep darkness, there are stars. They are scattered thinly across the vast distances. These stars are not like the ones you see blazing in the night sky. They are the elders of the galaxy. They are ancient. Many of the stars that live out here are older than the galactic disk itself. They formed over 13 billion years ago. They were born before the Milky Way had even gathered its shape. They ignited when the universe was still in its earliest, quietest dawn. Because they formed so early, they carry a very specific chemical signature. Astronomers call them metal-poor stars. In the language of astronomy, any element heavier than helium is referred to as a metal. These ancient stars contain almost no heavy elements at all. They were formed from the simple, pristine hydrogen and helium left over from the Big Bang. They have no iron, they have no calcium, they have no carbon. They are pure, they are simple, they are fossils made of light. These ancient metal-poor stars do not race through space. They do not follow the tight, fast tracks of the inner galaxy. They move with incredible slowness. They drift on wide, sweeping paths. They travel in long, looping arcs high above and far below the galactic plane. It takes them billions of years to complete a single, leisurely orbit. They are solitary wanderers in the dark. They shine with a soft, steady, fading glow. They are quiet sentinels keeping watch over the galaxy. They have been burning since the beginning of time. They will continue to burn long after you fall asleep. The halo might seem like a place of permanent stillness. It might look like a frozen museum holding the galaxy's oldest memories. But this is an illusion. The halo is active. It is participating in the life of the Milky Way. It is part of a massive, slow-moving cycle. The galaxy breathes. It circulates its matter. Astronomers call this slow respiration the galactic fountain. To understand this invisible machinery, you only need to think of the Earth. Think of the slow, steady water cycle that sustains our own planet. The sun beats down on the surface of a wide, quiet ocean. The sunlight warms the water. The water slowly evaporates. It turns into an invisible vapor. This vapor rises high into the atmosphere. As it travels upward, it moves away from the warmth. It enters the cold air high above the Earth. The vapor begins to cool. As it cools, it condenses. It gathers together to form soft, heavy clouds. Eventually, those clouds release their moisture. The water falls gently back down to the ground as rain. The rain waters the soil. It feeds the forests. It flows into rivers. It returns to the ocean. The cycle completes, and then it begins again. The Milky Way operates in the exact same way, but this cycle does not use water. It uses cosmic gas, and it does not play out over weeks or months. It plays out across eons. Deep down in the flat, spinning disk of the galaxy, the environment is hot and active. Clusters of massive stars live fast and die violently. They explode in cataclysmic events called supernovas. These explosions generate unimaginable heat. They superheat the surrounding interstellar gas to millions of degrees. This boiling gas cannot stay contained within the flat disk. The intense pressure forces it to expand. It pushes outward. It begins to rise. The heated gas is ejected upward, escaping the crowded spiral arms. It flows up through towering, invisible chimneys in space. It rises high above the galactic plane. It drifts up into the vast, quiet expanse of the dark halo. This is the cosmic evaporation. The galaxy is exhaling. It is breathing its heated material out into the dark. As this gas travels higher into the halo, it moves far away from the heat of the busy disk. The environment in the halo is freezing and empty. The hot, rising gas slowly loses its energy. It begins to cool down. It loses its violent heat. As it cools, it condenses. It gathers together into massive, quiet clouds suspended in the dark. It lingers there for millions of years. It hangs in the quiet heights of the galaxy, waiting. But gravity is patient. Gravity never stops pulling. Eventually, these cooled clouds of gas begin to feel the gentle tug of the galactic disk. They slowly begin their descent. They drift downward. They fall back toward the flat, spinning plane of stars. This is the cosmic rain. It is a slow, rhythmic return of matter, a gentle, invisible drizzle of cold gas. It takes millions of years for this rain to finally reach the surface of the disk. You cannot hear it fall, you cannot see it land, but it is happening all around us. The returning gas is heavy and rich. It has been enriched with the heavy elements forged in those ancient supernovas. It brings carbon, oxygen, and iron back down to the spiral arms. It drops fresh material directly into the star-forming nurseries. This cosmic rain waters the galactic soil. It provides the exact raw materials needed to build new stars, new planets, and new worlds. The Milky Way is not a static object. It is not a closed system. It is a living, breathing engine of renewal. It exhales hot breath into the dark. It inhales cool, refreshing rain. It circulates its matter through the vastness of the halo in a quiet, unending loop. This cycle keeps the galaxy alive. It regulates the formation of stars. It is a process of perfect, unhurried balance. Everything is recycled. Everything is reused. The atoms currently resting inside your own body have participated in this cycle. The iron in your blood might have once been blasted into the halo, cooled in the dark, and rained back down onto the disk millions of years before the Earth was even formed. You are part of this slow, eternal weather system. As you lie in your bed, let the image of this slow rain settle into your mind. Slow your thoughts to match its pace. Picture the ancient, metal-poor stars drifting silently in the dark. Picture the warm gas rising softly into the night. Picture the heavy, cool clouds forming high above the galaxy. Picture the gentle, invisible rain falling back down across millions of years. There is no rush. There is no urgency. The galaxy has all the time in the world. It moves at the pace of deep time. You can let go of the day's speed. You can let go of the need to hurry. You can align your breathing with the slow, steady respiration of the Milky Way. The universe is exhaling, the rain is falling, the ancient stars are keeping watch in the dark. You are safe to sleep. We have journeyed incredibly far. We have drifted through the sparse, freezing darkness of the galactic halo, watching the slow, rhythmic rain of ancient, cooled gas falling patiently back toward the spinning disk. But you do not live in the halo, and you do not sleep in the crowded, brilliantly lit metropolis of the galactic core. It is time to leave the grand, sweeping architecture of the Milky Way behind and make the long, quiet journey back. It is time to return home. Imagine drifting down from the quiet heights of the galaxy, plunging back into the glowing, flat plane of the stars. You pass through the bustling, crowded lanes of the major spiral arms, leaving the blinding blue giants and the sprawling, chaotic stellar nurseries behind. You are heading toward a much quieter, much more unassuming stretch of cosmic real estate. You are navigating toward the Orion Spur, aiming directly for the faint, steady warmth of a single yellow star. But as you arrive in our immediate cosmic neighborhood, the environment fundamentally changes. The dense, thick fog of interstellar gas and heavy dust that characterizes much of the galactic disk suddenly clears. The space around our solar system opens up. It becomes remarkably clear, remarkably thin, and profoundly quiet. You have entered the local bubble. We live inside a massive, invisible cavity in space. It is a sprawling, irregular void stretching approximately 1,000 light-years straight across. Give that measurement a full beat of silence in your mind. 1,000 light-years. If you could travel at the absolute maximum speed allowed by the universe, it would take you 10 centuries just to fly from one side of this empty room to the other. For a long time, The existence of this vast emptiness was a mystery. Space in the galactic disk is not supposed to be this clear. Typically, the interstellar medium is filled with a continuous, delicate mixture of gas, plasma, and microscopic dust grains that weave through the stars like a thin fog. But our immediate neighborhood is essentially hollow. The explanation for this massive cavity lies in the deep, violent past. Millions of years ago, a cluster of massive, powerful stars lived short, brilliant lives in this exact region of space. When those giant stars reached the ends of their lifespans, they did not fade quietly into the dark. They exploded in a rapid, cataclysmic series of supernovae. The combined force of those ancient explosions acted like a colossal cosmic snowplow. The powerful shockwaves pushed outward in all directions, sweeping thousands of light-years of surrounding gas and dust away, clearing a massive, hollow sphere in the interstellar medium. But you must remember the slow, patient scale of cosmic time. The violence of those explosions vanished millions of years ago. The blinding flashes have long since faded. The crushing shockwaves have slowed, halted, and cooled into thick, dense walls of gas that form the outer boundary of this cavity. What remains today is not a chaotic disaster zone. It is a sanctuary. The local bubble is filled with an incredibly thin, diffuse, hot gas. It is a quiet, settled emptiness. By clearing out the dense, obscuring dust, those ancient explosions inadvertently created a calm, clear window for our solar system to drift through. We are sailing across a calm, open cosmic sea, moving safely inside a quiet room built by the ghosts of dead stars. Yet even within this sprawling, empty cavity, the space is not entirely uniform. The local bubble is not a perfect vacuum. As our Sun carries its family of planets on its 225 million-year orbit around the galactic center, it glides through varying subtle textures of the interstellar medium. Right now, at this exact moment in cosmic history, our solar system is not traveling through completely empty space. We are actively drifting through a delicate, wispy structure known as the local interstellar cloud, or the local fluff. The name is highly appropriate, and it demands a restrained understanding. Do not picture a thick, heavy storm cloud looming in the dark. The local fluff is an incredibly faint, fragile gathering of hydrogen atoms, helium, and microscopic grains of cosmic dust. It is so impossibly thin that it is far less dense than the best artificial vacuum ever created in a laboratory on Earth. If you were to hold out an ordinary coffee cup in the middle of this cloud, you would likely catch only a handful of individual atoms. Yet despite its fragile nature, this cloud stretches for roughly 30 light-years across. It is a soft, drifting mist of cosmic material suspended silently within the larger emptiness of the local bubble. Our entire solar system, the Sun, the Earth, the distant icy bodies of the outer planets, and the very room you are resting in right now, is submerged in this gentle mist. We have been drifting through the local fluff for tens of thousands of years, and we will continue to glide through it for thousands more before we finally emerge into the clearer space beyond. When you imagine our solar system plunging through an interstellar cloud at hundreds of thousands of kilometers per hour, it is biologically natural to picture a dramatic collision. We are wired to expect friction, turbulence, and violent resistance when massive objects move at high speeds. But that is not how the universe operates on this scale. The interaction between our home and this cosmic mist is not a collision. It is not an explosion. It is a masterpiece of gentle, magnetic physics. As the Sun burns, it constantly exhales a steady stream of charged particles and magnetic fields outward in all directions. This continuous outpouring of solar breath creates an immense, invisible protective bubble around our entire solar system. This shield is called the heliosphere. It extends far beyond the orbits of the outermost planets, wrapping the Earth and our neighboring worlds in a vast, protective magnetic cocoon. As our solar system plows through the local fluff, the heliosphere is what meets the cloud first. When the leading edge of our sun's magnetic bubble encounters the drifting hydrogen atoms of the interstellar cloud, there is no sound, there is no flash of light, there is no violent shockwave or sudden turbulence. Instead, the physics of this encounter plays out as a soft, continuous deflection. The magnetic fields of the heliosphere meet the faint magnetic fields of the local fluff, and they simply press gently against one another. It is a slow, elegant brush of opposing forces. When the Voyager spacecraft, launched by humanity decades ago, finally crossed this exact boundary, leaving the heliosphere and stepping out into the interstellar medium, their instruments did not record a chaotic, violent border. They recorded a transition that was astonishingly peaceful. The data described the crossing as something akin to the transition between still air and a gentle breeze. The heliosphere acts as a perfectly tuned invisible shield, deflecting the majority of high-energy cosmic rays and simply sweeping the delicate mist of the local fluff aside. It parts the incredibly thin gas the way the smooth, curved hull of a slow-moving ship parts calm, deep water. The boundary of the heliosphere expands and contracts gradually, responding to the faint pressure of the interstellar medium like a quiet, drawn-out breath. The solar system glides forward, enveloped in its own quiet, protective bubble, sliding effortlessly through the mist. This is the profound, layered architecture of your immediate cosmic address. As you lie in your bed, perfectly still in the dark, you are safely sheltered behind multiple layers of quiet protection. The walls of your home shield you from the wind. The Earth's atmosphere shields the planet. The sun's heliosphere sweeps the cosmic mist away with infinite, magnetic care. And all of it rests safely inside a 1,000 light-year wide bubble, a calm, empty sanctuary carved out millions of years ago, holding the space open for your rest. There is no friction, there is no turbulence, there is only the gentle brush of invisible fields carrying you softly through the night. High above the horizon, under a truly dark sky, far from the glow of city lights, the Andromeda Galaxy appears as a faint, unassuming blur to the naked eye. It is a spiral galaxy much like our own, a vast and ancient structure containing hundreds of billions of stars lying over 2 million light-years away. Because it looks so delicate and so distant, it is incredibly easy to mistake it for a permanent, motionless fixture of the deep background. But that stillness is an illusion of perspective. Andromeda is not a passive neighbor, it is moving steadily, inevitably, toward us. In the grand machinery of the cosmos, galaxies do not simply drift at random. They are guided by the deep, unyielding currents of gravity. Together with the Milky Way, Andromeda is the dominant anchor of our local group, and the mutual gravitational attraction between our two massive spirals is pulling us together across the intergalactic void. We are falling toward one another through the dark, and we know exactly when this journey will reach its destination. In 4.5 billion years, Andromeda will arrive. Give that timeline a moment of quiet reflection. 4.5 billion years. That is roughly the entire lifespan of the Earth, played out all over again. By the time Andromeda finally reaches our doorstep, the continents on our planet will have shifted into completely unrecognizable shapes, and our sun will be nearing the late, swollen stages of its life. But the galaxy itself will endure, and it will be fundamentally transformed. When astronomers and physicists describe this upcoming event, they often use the phrase cosmic collision. It is a term that instinctively triggers a biological sense of dread. We are wired by our earthly experiences to associate collisions with sudden violence, with impact, and with chaotic destruction. We naturally picture a cataclysm. But if you are to truly understand the fate of our home, you must completely remove the panic from this concept. There will be no cataclysm. The reality of this galactic meeting contains no violence at all. The fear of a physical impact is a failure to comprehend the true scale of the universe. To understand why this event is entirely safe, you must remember the fundamental underlying physics of our cosmic home. Space is overwhelmingly, unfathomably empty. The stars that make up the Milky Way and Andromeda are separated by immense, staggering distances. Even in the seemingly crowded lanes of the spiral arms, the physical space between individual suns is an almost perfect void. If you were to shrink our sun down to the size of a single grain of sand, the nearest star would be another grain of sand resting more than 30 kilometers away. Because of this vast, built-in spaciousness, direct collisions between individual stars during this event are almost mathematically impossible. To properly visualize what will happen, do not picture two solid objects crashing together. Instead, picture two massive flocks of birds flying through each other in the open sky. Imagine thousands of starlings moving together in a dense, sweeping cloud, intersecting directly with another enormous flock flying from the opposite direction. As the two groups meet, the flocks completely overlap. They pass straight through one another, their overall shapes shifting, folding, and blending as they mix in the air. Yet, despite the apparent chaos from a distance, not a single bird strikes another. The open air between the birds is generous enough to allow perfectly safe passage for everyone. A galactic merger operates on this exact same principle, simply played out across millions of light years. It is not a crash, it is a serene entanglement. It is a slow, graceful passing of light through light. As Andromeda approaches, the visual experience of the night sky will begin to change, initiating a transformation that will unfold over hundreds of millions of years. This is not speculation, this is established physics. Over countless generations, that faint smudge in the northern sky will grow larger and more pronounced, eventually dominating the heavens. As the two immense gravitational fields begin to interact, they will not shatter. Instead, they will warp, bend, and stretch. The perfect flat spirals of both the Milky Way and Andromeda will be gently pulled out of shape by the sheer scale of the tidal forces at play. Immense tidal tails, long sweeping ribbons of stars, gas, and dark matter, will be drawn out into the dark, curling outward around the merging galaxies like delicate threads suspended in a slow-moving current. The process will unfold with the ultimate slowness of deep time. The two galaxies will pass completely through one another, reach the furthest edge of their gravitational leash, and then slowly fall back together again. Their central black holes will begin a slow, tightening spiral toward one another, and eventually the vast motion will begin to settle. After billions of years of this slow, elegant dance, the Milky Way and Andromeda will cease to exist as separate, individual spirals. They will fold completely together, merging their ancient histories, their star-forming gas, and their billions of suns into a single, massive elliptical galaxy. Astronomers have already given this vast, future home a name, Milky. But here, as we look into the deepest stretches of the future, we must confront an honest uncertainty. We have mapped the trajectories. We understand the overarching physics of the merger. We know that the gravity of both systems will inevitably draw them into a single, unified whole. But we do not know exactly what the core of Milky will look like. When those two supermassive black holes finally meet and merge in the new center, and when the remaining cold gas of both galaxies is driven together, the outcome remains a profound mystery. Will the merging of these two immense gas reserves trigger a massive galaxy-wide wave of new star formation, lighting up the core with a blinding, fierce brilliance? Or will the collision of gas strip the new galaxy of its star-forming material entirely, leaving behind a quiet, aging structure filled only with the soft, steady, fading glow of older red suns? We do not know exactly how that final architecture will settle into the dark. The honest uncertainty of science demands that we admit the limits of our predictive models when dealing with systems this immensely complex. What we do know, with absolute certainty, is that the night sky will be forever changed. The familiar, pale band of the Milky Way that arches across our current sky, the gentle river of light that has watched over every human being who has ever lived, and every ancestor who walked the ancient earth, is a temporary arrangement. It is a passing phase in a universe that refuses to stand still. The stars will not fall, and the galaxy will not be destroyed, but the map will be completely redrawn. The glowing spiral we call home is simply preparing to become something else, something larger and more magnificent, guided by the patient, unyielding hand of gravity. As you lie in the quiet of your room, there is no need to feel small or alarmed by this inevitability. To know that the universe operates on scales that dwarf the entire lifespan of our planet is not a reason for dread. It is a reason for profound awe. You are resting inside a structure that is moving toward a grand, luminous future, participating in a choreography that will outlast time as we understand it. The galaxy is turning, Andromeda is drifting closer, and the universe is handling the details with infinite, frictionless care. When we look at illustrations of the Milky Way, it is incredibly easy to believe that the map is finished. We see a clean, perfect spiral drawn in textbooks, and we naturally assume that every star has been counted, every dust lane charted, and every boundary neatly defined. We take comfort in the idea that the boundaries of our home are known, but as we have seen, mapping a galaxy from the inside is a profoundly difficult and frustrating task. We are deeply embedded within the galactic disk. Attempting to chart the true three-dimensional shape of the Milky Way from Earth is exactly like standing in the middle of a dense, overgrown forest at midnight, looking along the line of the trees and trying to draw an accurate map of the entire woods. You cannot see the overall shape of the forest from that vantage point. You only see the thick depth of the timber immediately surrounding you. Furthermore, the space between the stars is not empty. Thick curtains of interstellar dust made of microscopic grains of carbon and silicates weave heavily through the spiral arms, throwing massive, impenetrable shadows across our line of sight. Because of this, we must acknowledge that our map is beautifully, wonderfully incomplete. The Milky Way remains a paradox of light and dark, a pattern we can measure but never fully hold, and yet that very incompleteness is what makes it beautiful. It is an unfinished draft, but the map is not static. High above the Earth's atmosphere, drifting silently through the freezing vacuum of space, a single spacecraft is working quietly in the dark. This is the Gaia Observatory. It does not take a single, flat photograph. Instead, it gently traces the exact positions, motions, and brightness of over 2 billion stars with its patient gaze. As it watches, the Milky Way slowly transforms from a blur into a precise three-dimensional map. The spacecraft's quiet measurements reveal subtle motions, vast distances, and enormous structural patterns that were once completely hidden in the haze of starlight. With every passing day, the Gaia spacecraft is still returning data, changing our understanding of the galaxy daily. This is confirmed science. This is what the data shows. Over years and decades, the map sharpens, turning wandering points of light into a coherent, living whole. Yet, for every region we illuminate, another remains wrapped in deep shadow. Every discovery adds another brushstroke to the portrait of our home. But the mystery only deepens. The investigation is ongoing. And the investigation must continue, because the universe refuses to stand still. The universe is expanding, the galaxy is rotating. The immense, unseen scaffolding of dark matter continues to hold billions of stars in their lanes as they sweep through the dark. The Radcliffe wave continues to undulate. ancient metal-poor stars continue to rain slowly down from the halo. The deep currents of gravity never pause. Because the cosmos is in perpetual motion, we must keep watching. Instruments are being built right now to peer deeper into the dust. On remote mountain peaks and in clean laboratories across the world, engineers are carefully grinding massive glass mirrors. Physicists are designing incredibly sensitive sensors that will eventually catch the faint, ancient infrared and radio light currently making its way across the interstellar void. We are constantly reaching outward, trying to hear the quietest whispers of the cosmos. But you do not need to build a telescope to participate in this grand, continuous motion. You do not need to travel into the galactic halo to experience the physics of the universe. It is time to leave the vastness of the spiral arms behind. It is time to step out of the sweeping intergalactic wind, glide back through the quiet sanctuary of the local bubble, and bring your awareness back to your immediate surroundings. Bring your mind back to the quiet of your dark room. Feel the heavy, comforting stillness of your mattress supporting you. Feel the slow, steady rhythm of your own breathing. Notice the complete lack of turbulence. Your room is completely quiet. The shadows in the corners are motionless. The air resting against your skin is perfectly still, but that stillness is an illusion of human scale. You are physically participating in an intergalactic journey at this exact second. Right now, the Earth is moving through the galaxy at approximately 230 kilometers every second. Give that number a final moment to settle in your mind. 230 kilometers every second. In the time it took for you to hear that sentence, everything you have ever known moved roughly 1,000 kilometers through deep space. The Earth is spinning. The Sun is carrying its family of planets on its 225 million-year orbit around the galactic core. We are swaying, rising, and diving through the colossal crest of the Radcliffe Wave. And the entire Milky Way, carrying our Sun, our planet, and every single star you can see in the night sky, is racing across the universe at over 2 million kilometers per hour. We are caught in a cosmic tug-of-war, being pulled by the massive gravity of the Great Attractor, while simultaneously being pushed by the desolate, unyielding emptiness of the dipole repeller. This precise motion is happening at this exact second. You are caught in a cosmic wind. You are a traveler riding a wave generated by the largest structures in the known universe. It is entirely natural to look at these unfathomable numbers and this scale of motion and feel a sense of overwhelming smallness. But this smallness is not insignificance. Every single atom in your body that is heavier than helium was forged in the blinding nuclear furnace of a star. You are a biological mosaic constructed from the shredded wreckage of consumed worlds and ancient galaxies. The history of the Milky Way and the history of your own body are the exact same timeline. You are not separate from the magnificent machinery of the cosmos. You are the universe, thinking, seeing, and resting within itself. You do not need to brace yourself against the speed because the galaxy carries you with infinite, frictionless care. You do not need to hold on to the details of the map because the universe will handle the motion for you. The galaxy is turning, Andromeda is drifting closer, and the universe is exhaling softly into the dark. You can let your body sink into the stillness of your bed. You can let the day fade out completely. I am incredibly small, the universe is impossibly enormous, and simply knowing that is the most interesting and comforting thing in the world.